So here we are. Ooh, sorry, just getting. There we go. 10-2, example numero uno. So focusing on our steps, any distribution or combining of like terms first. I definitely have distribution that we need to do, and what cues me to that is the parentheses. So I'm going to start first by distributing that 2 to the negative 6m and getting negative 12m, and then the 2 times the negative 3 to get a negative 6. Is equal to, and I can see I have more distribution over here to do, so I'm gonna, continue on with that. I'm gonna continue with green. 6 times the 5m will be 30m, and 6 times the negative 1 will be negative 6. Yes, I am forgetting to draw my line down the middle. I'm on it. All right, so now that we have no like terms or anything like that to deal with, we can try to get all of our variables on the same side of the equal sign. Now, there is no wrong thing to do here. You can do either one. To avoid your negatives, you're going to go ahead and add your 12m to both sides. But let me be clear, even though we're doing it this way, it would not be incorrect to do minus 30m from both sides. You're just going to have to deal with a negative over here. But again, it's not incorrect. But for sake of consistency, we're going to move the smaller one over because we like to avoid the negativity, as Mrs. G would say. That negative 12m and positive 12m canceling out because the opposite or the inverse of a negative 12m is a positive 12m, leaving me with negative 6 equals 30 plus 12 is 42m, and carrying down my minus 6. So now I'm trying to get that variable term, that x term, in this case m, that 42m, I'm trying to get that by itself. That is being prevented from being alone by this negative 6 here, so I'm going to do the opposite of a negative 6 and add 6 to both sides. Again, doing it to both sides, making sure you're keeping that equal sign equation balanced. The negative 6 and positive 6 over here actually cancel out to a 0, right? There's nothing there. We have to write the number 0 because 0 is a number, and that's okay. Over here, my 42m carries down, and over here, my negative and positive 6 also cancel out again. Now over here, when I could write plus 0, 42m plus 0 is still just going to stay 42m. So that's why we don't write it over here. We write it on the left side of our equation because if not, there's nothing there, and that would be really bizarre if there was nothing there. We need something to work with over there. Boom. All right, so 42 is being multiplied by m. The inverse of multiplication is division. 42 divided by 42 is 1. M carries down. And 0 divided by anything is still going to be 0. So we have m equals 0. Now, taking a look at my check, remembering that we're following gems and working from the inside out when we're doing this check here. Starting first with just rewriting the original equation. 2 parentheses negative 6m minus 3 equals 6. Now this one, because there's like parentheses already in it, it's going to be really important when you're substituting in your parentheses that you don't mess anything up. Mrs. G would say you can just erase and replace here. Replace with those empty parentheses first. Then we can go ahead and substitute in our 0 every place there was a m. Now, a lot of you guys have this automatic need or want to distribute, but that can't happen. We're not distributing unless we're solving an equation. We're working from the inside out, order of ops, groupings first. Inside these groupings, I have multiplication and subtraction going on. Multiplication comes before subtraction, so I'm doing these multiplications first. 2 parentheses negative 6 times 0 is 0, and I'm just carrying everything else down. 0 minus 1, boom. It is going to be essential that you show a few steps in between to get full credit. 0 minus 3 is negative 3. 0 minus 1 is negative 1. 2 times negative 3 is negative 6. Negative 6 times 1 is negative 1. Boom. That's a true statement. Negative 6 is equal to negative 6. Therefore, our solution of m equals 0 is correct. Unless, of course, we made a mistake in our check somewhere.